Hello, good afternoon, Professor G and friend. This is my second presentation about cognitive assistant deep net model detection of cardiac arrhythmia using Jetson Nano. My name is Evina. Okay, for the article and journal information, this is the title of the article is Cognitive Assistant Deep Net Model for Detection of Cardiac Arrhythmia, and the journal publication in Biomedical Signal Processing and Control in 2022. And when we go to the journal, we will see that this journal is Q1, Scopus Q1, and the impact factor is 4.9. And next is about introduction of this article, which is first that's all about heart attacks. Heart attacks are major cause of death globally. 70.9 million people die each year due to the cardiac abnormalities, estimating 21% of worldwide death. So this is a big impact of the heart attack, which is almost 21% worldwide death. And 50% of them is due to the cardiac arrhythmias. So the cardiac arrhythmias are irregularities in the heartbeat, including when it is too fast or too slow. And how we can recognize it is irregularity, too fast or too slow. We usually use the ECG or electrocardiography in the main diagnostic procedure for detecting arrhythmias. Okay, next, the background is the model performance of ECG depend on the feature extract. However, such as model are not accurate because of morphological feature variety on time and circumstances. So the analysis of detection cardiac arrhythmia is generally about 70%, is not higher than 70, it's around 70%, which does not meet the clinical requirement. So the good trend is maybe more than 19. So 100% is best and 70% is not quite meet the requirement. And therefore, there is a need for prediction model to assist the doctor in early diagnosis. And we using NVIDIA Jetson Nano. So why we use NVIDIA Jetson Nano? Because of we need workstation with high performance GPU. So the deep learning will be very best, it make the good performance of deep learning. And we using NVIDIA Jetson Nano, which is known as energy efficiency, portability, and high performance GPU. So the Jetson Nano have high performance GPU with low energy and saving costs. And they propose a novel deep learning to facilitate the automatic classification of ECG into 7 types. They call DeepNap. Yeah, this one. So the objective of the article is the DeepNap model for detection of cardiac arrhythmia using Jetson Nano. This is the research flow. We go to the material and method, this is the research flow and Jetson Nano installation. And we see in the first step, this is ECG pre-processing first. The database is from MIT BIH. And after we got the data set database, they remove of noises. So the first time they got the noise signal is like this, and they remove the noise, and then it will be like this, the noise signal. And then they go to the ECG bit segmentation. This is the noise signal, and then they detect the peak of the bit, and then they segmented the bit. And after they segment it, they go to deep learning framework. They label it dataset. So the ECG peak, they label it, and then they split to data test, training data, and validation data. And then for the training and validation, they do the deep net model. And then after they do the deep net model, they deploy on framework and training model on NVIDIA Jetson board. So after they get the deep net model, they deploy into NVIDIA Jetson. And the test data is go here. Yeah, after they deploy in the NVIDIA, so they test in the trained model. Yeah, after the NVIDIA, and then they got the training model, and test data go to training model, and they will got the prediction of cardiac arrhythmia. So we can see this is the Jetson Nano installation. As the first presentation, they use Wi-Fi, connect to the computer, and they connect to the monitor and mouse. Okay, next, this is the information more detail about a DeepNet. They propose a DeepNet model to effectively classify 7 types of ECG bits. They develop a novel structural CNN unit is construct using pointwise convolutional and dipwise separable convolutional. And structural CNN units with different kernel are used to design the DeepNet models. And the proposed model DeepNet will be compared with the AlexNet and ResNet 18. So this is the data set. So they got the data set from MITBIH arrhythmia database, and then they separate them into, this is the total data. The total ECG bits is 14,213, and then 80% is go to the training and 20% is go to testing. And this is the distribution. Yeah, so the distribution is the biggest majority, 27% is go to the normal sinus rhythmic, or we call it N. And then the second is left bundle branch block, or we call L. And the third classify is right bundle branch block, we call it R. And then the fourth is premature ventricular contraction, we call it V. And flash speed, we call P. Atrial premature base, we call A. And fusion of normal and flash speed, we call F. So this is 7 classification of ECG bits. After we got the data set and we separate them to the training 80% and testing 20%, and then we go to the DeepNet model. They constructed the structural CNN. This is the structural CNN unit. First, they have a pointwise convolutional, and then they go to the dipwise convolutional and concatenate it and go again to the pointwise convolutional. And so the structural CNN is in the orange color. This, yeah, after structural CNN, yeah, they do the rectified linear unit and then convolutional layer and so on. And the end is they go to fully connected layer. So this is the purpose of the deep, deep net model. And we get the result. So the result is they compare deep net model and ResNet and AlexNet model. And we can see that in the confusion matrix, this is the confusion matrix. We got in the AlexNet, and 2188 68. It means the total data set they can predict accurately, they can predict correctly. So we see in here in the red line circle right, this circle right, it is the correct prediction of AlexNet, ResNet, and DeepNet. If we see one by one, we compare one by one, so we can see that the DeepNet is more have correctly prediction, like this one, 2180 68 DeepNet is same with other, and then 1614 is higher than ResNet and higher than AlexNet. And the third 1435 is the lowest, but after P, in the P, DeepNet is compared with another is similar, and for the phi, DeepNet is same with another. And for the A, DeepNet is the best, the highest, 333. We compare with ResNet is just 303, and AlexNet is just 329. And for the F, DeepNet can guess correctly 193. So if we go generally overall, if we see that DeepNet is very good rather than AlexNet and ResNet. And we see another comparison of performance measures, which is we want to know about the precision, recall, specificity, and F-score. And the average, this is the AlexNet, this is ResNet, and this is DeepNet. We see that the score is around 98% for AlexNet, and for ResNet is about 99%, and for DeepNet is about 99%, but higher than ResNet. Yeah, if we see the precision, the DeepNet in average, the DeepNet is higher rather than ResNet. So the DeepNet precision is 99.42, and ResNet is just 99.27, and AlexNet is just 98.62. Yeah, we can see that precision DeepNet is higher. And recall, it's also higher. The DeepNet, we can reach 99.26. Oh, ResNet is just 97.43, and AlexNet is just 98.73. Yep. And if we see specificity, we also have the higher score, 99.660, and for ResNet is just 99.56, and for the AlexNet is 99.39. And the last one for F-score, the DeepNet is also get the higher score, 99.34. ResNet is just 98.30, and for AlexNet is just 98.66. And for the accuracy, accuracy for the deep net is highest to 99.56. ResNet is just 99.07, and for AlexNet is just 98.98. So if we see overall in the confusion matrix and performance measure, we know that proposed model DeepNet is very good. It's higher rather than ResNet and AlexNet. And for the this is the average. We can see that our proposed DeepNet is in green color is higher rather than red color ResNet and AlexNet blue color. We can see that our proposed model DeepNet in green color is higher rather than another. And if we compare again with another model in CNN, deep neural network, Disney, and another in the another paper, we can see that our accuracy is higher. It's very high, 99.56, and none of the another literature is higher than us. So our proposed model DeepNet is very high. It's very good. And for the discussion, for its fine-tuned model performance like precision, recall, specificity, F-score, and accuracy are calculated and summarized. And it is evident that our proposed model have achieved highest test accuracy at 99.56. Well, AlexNet is just 98.98, and ResNet is just 99.09. And for the comparison of performance measure of CNN models, so for state of art study attempt by many researchers, and the performance metrics achieved by them is shown in here. And our accuracy is very high, higher rather than another literature. So the conclusion is, in this paper, deep model has been proposed to classify 7 types of ECG bits. Pre-trained CNN model AlexNet and ResNet are also explored on the same denoise data with same number of classes to make a fair comparison. We introduce a structural unit which can extract both global and local features at a time. Our DeepNet model is designed using this structural unit. After design the layer architecture, the model is fine-tuned with various model training parameter. System-level implementation of our proposed DeepNet model is done. The model is trained and testing using NVIDIA Jetson Nano. It is observed that among all models in literature, our model is achieve the highest accuracy of 99.56%. Okay, that's all. Thank you for your attention. Goodbye.